Welcome everybody to our spring versions of Grand Rounds for the Department of Medicine, and delighted to have Dr. Barnes virtually visiting us today. And introducing Dr. Barnes will be our own Dr. Carrie Gleason from the Division of Geriatrics and Gerontology. So Carrie, handing it off to you.
Thanks, Dr. Schnapp. I am so delighted this morning to present an amazing leader in our field of Alzheimer's disease research and a dear colleague of mine. Dr. Lisa Barnes is the Alla V. Solomon Jesmer, Professor of Gerontology and Geriatric Medicine, endowed professor at Rush University Medical Center. And she's also the director of the Center for Excellence in Disparities in HIV and Aging and the associate director for the Rush Alzheimer's Disease Research Center. She's one of the most sought after speakers, as we can attest to. I think we had to book you out more than a year in advance. And she's served on NIH advisory councils and as many as 5 external advisory boards and various centers throughout the country. I highlight these notable invitations from others in the field to emphasize how influential and respected Dr. Barnes is. She, for many of us doing this work, myself included, she's influenced how we think about our data and our analyses in really impactful ways. And she does all this while still leading active funding. So she has the Minority Aging Research Program, or MARS, that has one of the few population-based studies enrolling African Americans. She's published over 300 papers, some of those very important, influential papers, including some that have highlighted neuropathological data from African Americans. She also was influential in helping us understand the genetic influence of the ApoE4 genotype in those with African ancestry. So she has incredibly accomplished and still manages to be an active mentor and teacher. And very importantly, I think she herself would say she's proud of her community partnerships as well. So I'm pleased to turn things over to my very talented and generous collaborator and colleague, Dr. Lisa Barnes.
Thank you so much for that really, really kind introduction, Dr. Gleason. Thank you all. I want to thank Dr. Gleason and Dr. Schnapp for the invitation to come and present today to your group. It's really my honor, and I wish I could be there in person. I will be there in person tomorrow for another event that you're having. So my title is Cognitive Aging in Older African Americans. And of course, I want to acknowledge the Solomon Carter Fuller Celebration founding team, Ms. Charleston, Charlie Daniel, and Dr. Dorothy Edwards for starting this wonderful acknowledgement of Solomon Carter. And I feel like I am following in the footsteps of some really important people here. I have no financial disclosures. So by way of sort of a background of what I will talk about today, I want to describe 2 of the studies we have here at the Rush Alzheimer's Disease Center. The Minority Aging Research Study, MARS, which you heard from Dr. Gleason, and another study that I often merge my data with, the Rush Memory and Aging Project. And then I want to talk about some of the risk factors for cognitive aging that we have published and are currently working on in older African Americans. And I've picked a lot of risk factors because I want to show you the breadth of what we can accomplish with this type of a cohort study. And so I will go through a lot, and not in a great bit of detail, but just to give you a sense of what we've discovered. And then at the end, I will share some recent data that we are currently in the process of writing up, looking at brain pathologies underlying cognitive impairment at autopsy among African Americans. So as I'm sure many people in the audience are aware, Alzheimer's dementia has become a huge problem for our rapidly aging population. In 2021, we published a paper to sort of forecast the problem with Alzheimer's, and in 2020, it was thought that over 6 million adults over the age of 65 had clinical Alzheimer's dementia. But as you can see, that number is going to more than double to be more than 13 million by 2060. And because Alzheimer's is, very highly age-related, the numbers are going to increase dramatically for those 75 and older. At the same time that we are seeing this demographic shift, or this rising problem with Alzheimer's disease, we're seeing a growth in the population of diverse people as well. This slide shows data from the US Census with population projections through 2060 for different racial and ethnic groups. And what you can see is that minoritized populations will have a rapid growth through 2060, with Hispanics actually having the largest increase overall. This rapid growth for many minoritized groups will be particularly problematic because of disparities in the burden of dementia across racial and ethnic groups. So this is the disparity that is often discussed. These data come from the Kaiser Health System in Northern California. The investigators looked at medical records of over 270,000 Kaiser enrollees to determine the age-adjusted dementia incidence rates by race and ethnicity. And they found that dementia incidence rates were highest in African Americans, followed closely by American Indian and Alaskan Natives. And we've seen these kinds of disparities for many brain health outcomes, not just dementia. But another way to look at this dementia disparity is to examine age-related change in cognitive function, because cognitive decline is the hallmark feature of dementia. So healthy brain aging would be the maintenance of cognition over time. But most of us, unfortunately, will experience some kind of cognitive decline in later life. And for some people, this decline may eventually surpass a threshold recognized as a clinical manifestation of dementia. But there's a lot of heterogeneity in the degree of cognitive decline in older people. Some decline really rapidly, some decline more slowly. What we want to understand is what determines the rate of decline, and can we identify risk factors for decline in dementia or protective factors for healthy brain aging. Now, when it comes to studying cognitive aging among older African Americans, there are a few challenges that we have to surmount. One is that much of what we know about cognitive aging in African Americans actually comes from cross-sectional studies. It's well documented that older African Americans tend to score lower on neuropsychological tests compared to older white adults. However, we know that performance on these cognitive tests are highly correlated with education, and there are often large differences in education, both years and quality, between African Americans and white Americans. And while some studies show an attenuation of racial differences in test performance after adjusting for education, that's not always the case. And in fact, we know that cognition is influenced by factors beyond education. Some of them here are listed here on the slide. And of course, many studies, can't possibly control for all these things. And so we are left with a bit of a quandary here. Another problem that we face in advancing our understanding of cognitive aging in African Americans is the lack of representation of African Americans in cognitive aging studies. One study that was published in 2020 looked at the largest 8 studies that are generating the bulk of knowledge on aging and dementia, large epidemiologic studies. And when they looked at the demographic breakdown of participants coming from these studies, they found that the largest percentage of participants was older white adults, about 79%. You can see the much smaller number for the other populations, namely with older African Americans, making up only 11% of participants in these studies, which is obviously a problem if African Americans tend to be disproportionately burdened by cognitive decline and Alzheimer's dementia, this population needs to be represented in these kinds of studies. So the objective of my program of research has been to build a longitudinal cohort study of older African Americans that will allow me to contribute to the knowledge base on cognitive aging and dementia by identifying early and late life factors, including, genetic markers, individual level experiences and behaviors, as well as environmental factors, and determine how they associate with cognition over time, how they impact the brain itself, and ultimately how they influence risk of disease. With the major goals being to create an infrastructure upon which we can ask novel questions that are not typically in the literature, increase inclusion and representation in science, and importantly, expand the narrative on aging for minoritized groups. So I started the Minority Aging Research Study in 2004 with these goals in mind. And at that time, it was a smaller cohort, but now it's close to 850 African Americans enrolled. And the only criteria to enter is that you have to be at least 65 years of age, and you cannot have dementia. We recruit from the community, from churches, senior buildings, and organizations in Chicago. And we do all of our testing in the community as well, in the participant's home, including a risk factor assessment and blood draw. We have really good follow-up rate, over 90% among those who are still living. And over time, about 10% have developed Alzheimer's dementia. And in 2011, we started to recruit for brain autopsy. And if we look across all of our cohorts, because getting brain autopsy from African Americans is challenging. And so you really have to combine studies to be able to get enough numbers. And so across all of our cohorts, we have about 180 autopsies to date. And this year, we are actually celebrating the 20th year of the Minority Aging Research Study. The approach that we use is a community-centered engagement outreach model where the goal is to foster bi-directional relationships between the community and the research team using a variety of culturally relevant strategies. And we try to build, culturally celebratory retention events that serve to keep people engaged, interested, and invested as partners. And our main tenet is giving back and strengthening community ties. So we are in the community almost constantly, putting on events and, returning results and explaining what we're finding, offering, education and resources. And we have, newsletters where we, also try to educate and inform our community and our participants about what their contribution means. So this is what the cohort looks like currently, about more than 800 self-identified African Americans. The cohort is mostly women, which is pretty characteristic of aging studies because women live longer. They're also more likely to volunteer for research. The current mean age is about 84, and they are relatively educated for an older African American cohort, about 14 years, which is also consistent with healthy, a healthy volunteer cohort. And the range of education, though, is quite broad. We have as little as 3 years all the way up to about 28 years of education represented. We've had quite a few people die since we started, and that's what sort of feeds our autopsy component. And we have also incorporated imaging, and we do longitudinal MRIs. So we have over 370 people who've gotten multiple MRIs, and about half of those who are still alive and active have agreed to brain donation at death. And as I said, we're currently in our 20th year this year. So Mars is completely African American, but sometimes I want to look across race to look at racial differences. And so there's another cohort here that's actually started before mine called the Rush Memory and Aging Project that's led by the director of our center, David Bennett. And this cohort consists of over 2,000 older people without dementia who come from Chicago and Northeastern Illinois. It's predominantly white. And they have all also agreed to annual detailed clinical evaluations with risk factor assessments and blood donation. Again, everything happens in the community. We never recruit from our memory clinic for these types of studies. Everyone in that study, however, has agreed to be an organ donor at death. And so that might be why, I know that's why the study is predominantly white, because you have to agree to give your brain in order to be in the study. But importantly, there's significant overlap in risk factors between my study, MARS, and the Memory and Aging Project, and we use the same harmonized cognitive battery. So this is our study design for both studies. We enroll people at baseline with no disease, and we document a host of risk factors. And then we follow people annually, every year, testing, their cognition and, documenting change in cognitive function over time, so we can relate the risk factors to cognitive trajectories. We also can relate these risk factors to incident disease, because over time, some people will develop dementia or mild cognitive impairment. And in those people who die and come to autopsy, we can determine how the risk factors may be operating through the pathology we see in the brain to lead to disease. So we've been following people for a long time now, and this is just a spaghetti plot that shows rates of change in our global measure of cognition plotted as a function of age. It's just a random plot of 150 people, and the different colored lines represent the two populations of African Americans and white Americans, and the length of each line represents change over time for each person. And you can see there's a lot of variability, both in where people start and how fast they decline. And this can be seen both across and within race. However, in work led by Dr. Bob Wilson, who's a senior neuropsychologist here at our center, he looked at racial differences in the longitudinal trajectories of these people in these two cohorts. And these are the predicted paths of change based on linear mixed effects models, where each line represents a 5-year path of change with people at different ages. And performance is plotted as a function of age. So the top panel is semantic memory performance, and the bottom panel is perceptual speed tests. White adults are shown by the green lines and Black adults by the blue lines. And what you can see is that white adults are performing better if you focus on the level differences. At every age, they're above Black Americans, which is what we see in the literature. And while everyone's declining over time, the slopes are mostly parallel, suggesting that both groups are declining at the same rate, except for at the oldest ages, where the slopes for Black adults are not as steep, and it looks like they may be declining a bit slower at older ages. So the data in our hands don't really seem to show a clear difference in rate of cognitive decline, a finding that we've replicated in a number of studies, including a population-based study called the Chicago Health and Aging Project. But we do have these persistent differences in level effects, where older white adults are performing better than older Black adults in our studies. And this is seen across other studies in the field. Remember, I showed you that picture of healthy brain aging. So, it's likely that Black adults are hitting that threshold to be called to have dementia, because they're starting off at lower levels. So for the past years, I've been focused on trying to understand if there are risk factors that may be relevant for cognitive aging in older African Americans that could perhaps explain why we see these lower levels of function in this population, because clearly it's not just based on education. So we focused on some of the more traditional factors that have been published in studies of older whites here, in work led by Zoe Arbanatakis, a neurologist in our group with expertise in vascular risk factors. We looked at the relation of BMI in late life on change in cognitive function in African Americans and whites. We found that although African Americans had higher BMI levels on average, lower BMI was related to faster decline in global cognition. This was also the case for semantic memory and episodic memory, which I'm not showing you here. I'm just showing you global cognition. So the gray lines on top, these are the slopes for white adults, and this solid line is people with low BMI, and you can see this same pattern in Black adults. Here are people with low BMI. So this relationship of low BMI with faster decline is the same across both groups, even though Black adults tend to have higher BMI. And again, you can see these level differences here, but really the slopes are not different. We've also looked at genetic risk factors, and ApoE is one of the strongest risk factors for Alzheimer's dementia. We know from several studies that ApoE, however, doesn't operate the same across race. Many studies have shown that the E4 allele has a weaker effect on cognitive decline in African Americans. And we know that the E4 has a selective effect on episodic memory. So in one of our studies, we hypothesized that the effect of E4 might be weaker in Black adults because most studies have used either very brief screening measures or only a global measure of cognition, potentially masking any selective effect on episodic memory. So in one of our studies, we found when we deconstructed cognition into different cognitive domains, that having at least one E4 allele was related to faster decline in episodic memory in both white and Black adults. So here are the data for whites. They're the longer lines because they have been followed for more years. And what you can see is that white adults with an E4 had faster rates of decline, just like Blacks with an E4, this shorter line. But when we looked at the other domains, we saw that this pattern persisted in other domains for white. So if you had an E4 and you were white, you declined faster in other domains, as shown here. I think this is working memory. No, sorry. Yeah, this is working memory. But if you were a Black adult, these lines here, and all the other domains, the lines were right on top of each other, suggesting that E4 had no effect on any other domains except episodic memory. In another study led by Lei Yu, a biostatistician in our group, we examined the relation of ApoE4 and TOM40, which is a neighboring gene to ApoE, with risk of Alzheimer's dementia in both African Americans and whites. TOM40 and ApoE are actually in disequilibrium in whites. And so it has been thought for a really long time that the TOM40 haplotype was not doing anything independent of E4 as far as its effect on risk of dementia. So when we looked at the effect of ApoE and TOM40 in whites, we saw, as you can see here, that yes, indeed, TOM40 is in linkage disequilibrium with E4, and the effect of both there's an increased risk for dementia in both, whether you have an E4 or a TOM40 allele. But when we looked at the data for our Black adults, we saw a different pattern. We saw that in Black adults, if you had a 523 long haplotype shown here, you had an increased risk. I'm sorry, this is for E4. If you had an E4, you had an increased risk. But the long allele did not have as much of an increase as it did in whites. So we had to put them on two different plots so you could really see that there's really quite a different pattern based on whether or not you have a long or a short allele. So here you have this neighboring gene that seems to be functioning differently in African Americans and whites. This finding was curious to us and prompted a former postdoc that I work with from Stanford, Casey Dieters, who's now an assistant professor at UCLA, to sort of deconstruct the clusters of haplotypes as a function of race and see whether the clusters are behaving differently across race. So looking at the clusters of participants, from the previous study, she saw a different pattern between African Americans and whites. So for people who had an E3 allele, the pattern was the same for whites and for blacks. You had these two clusters. But if you had the E4 allele, there was a different pattern. So whites had just two clusters compared to Black adults who had an additional cluster here in the short range. So the question, for her was, does this heterogeneity in this in Tom 40 on E4 impact cognitive decline among African Americans? And the answer was yes. The plot on the right shows you the relationship of the different haplotypes on rate of decline. And what you can see is that because of linkage disequilibrium, whites with E4 Tom 40, they're shown with a black line, and they have a fast rate of decline. You can't separate it because they're right on top of each other, the Tom 40 and the E4. But in our African Americans, they have both long and short, as I showed you before. They have the short cluster, and then they have here the long cluster. And we saw that there was a breakdown based on what kind of cluster you had. So if you had a long cluster, shown here in this gold line, you had a faster rate of decline, just like whites. But if you had the short cluster, either a 1 or 2 haplotypes, you had a much slower rate of decline compared to those with long. So here you can see that there is this heterogeneity based on what type of haplotype you have, likely due to admixture in older African Americans. Again, something that we would not have known if we didn't have African Americans in our studies, because we thought that, Tom 40 wasn't doing anything because most genetic studies only include older white adults. We've also looked at neuroticism, a well-established personality trait that predicts dementia in older white adults. And this is work led by my current postdoc, Emily Sermon. And she used 12 items from the NEO 5-factor inventory. In this study, we also are looking at the individual facets that comprise neuroticism, including anxiety, angry hostility, depression, and self-consciousness and vulnerability. The mean score in the sample was about 14 on a scale that ranged from 0 to 45. And we found in Cox models adjusted for demographics, shown in the model 1, that higher neuroticism was associated with an increased risk of dementia, even after adjusting for ApoE. And the graph on the right shows results from an accelerated failure time model indicating that those individuals who scored in the 3rd tertile, so they had over 17 on the scale, they experienced onset of dementia 3 years earlier than those in the 1st tertile. When we looked at the individual facets, we found that it was neither angry hostility nor anxiety was related to risk of dementia, but depression, self-consciousness, and vulnerability, they were all driving this greater risk for dementia in this population. Along a similar line, we have previously published work on depressive symptoms as a risk factor for decline in purpose in life as a protective factor in separate studies. But few studies have really looked at the interrelations of depressive symptomatology and purpose in life jointly. Because purpose in life is, a component of well-being, has been considered as a target for treating late life depression, we sought to understand the joint associations in older African Americans. And this is work that's led by Maud Wagner, a biostatistician in our group. So we found, similar results across both, factors, depressive symptoms and purpose in life. So the level of cognitive function was consistently worse for those with more depressive symptoms. But the level of change was similar, regardless of how many symptoms you had. That's shown on the left. On the right, we see a similar pattern, the purpose in life. Those with higher purpose in life had higher levels of global cognition, but we really didn't see any association with decline. To understand how these two factors interrelate, we compared participants across combined categories of depressive symptoms and purpose in life. The strongest effect was for those individuals with no depressive symptoms and higher purpose, But interestingly, we found that even in the presence of depressive symptoms, those with higher purpose had better cognition, a finding that may support evaluation of psychological therapies for depression that incorporate enhancement of well-being as a way to maintain cognitive health in aging. So these traditional risk factors appear to operate similarly in African Americans, even when the levels of the risk factor are different. But I started Mars to be able to understand whether we could identify risk factors that might be particularly relevant to older African Americans. It's pretty well accepted that race is a social political construct rooted in cultural identity and shaped by historic events. Because race is not biology, it's much more likely that the social conditions in which people are born, live, work, and play, and age, what we call the social determinants of health, that those are the factors that might give us a deeper understanding of cognitive aging in older African Americans. So in Mars, we try to leverage the social context in which people live to understand the aging brain. So for example, in one study led by Dr. Melissa Lamar, neuropsychologist in our group, we examined historical factors that shaped the lives of our older participants, namely, the Great Migration, which happened from 1916 to about 1970, where close to 6 million Black Southerners relocated to urban areas in the North and West to flee the oppression of the Jim Crow South. So leveraging this historic life experience, we examined the effect of geographic place of birth on late life cognition. All of our participants live in Chicago now, but we asked them where were they born and where were they living at age 12. And consistent with previous studies that have shown adverse health effects for Southern US birth, we found that participants who were born in the South or living in the South at age 12, shown by the green bars, had overall lower performance on our cognitive function tests. But there are many things that were different about the North and the South during that time. One thing that we know was different was the educational experience of African Americans. The African Americans that are in our cohorts now represent the first generation of African Americans to attend legally desegregated schools after the historic Brown versus Board of Education decision in 1954. Which ruled that separating children in public schools on the basis of race was unconstitutional, and this signaled the end of legalized racial segregation. So we asked participants about their experience attending a segregated school, and we found not a main effect of this experience, but we found an interaction of place of birth and school segregation, such that those who were born in the South who attended legally desegregated schools had the lowest performance on our cognitive measures compared to all the other groups, including their counterparts who were also in the South attending segregated schools. So it's plausible that the experience of integrating schools in early life during a tumultuous racial climate may have been an early life stressor. And 40 to 50 years later, when these people are in our study and we're measuring their cognition, we can see the impact of this stress on cognitive test performance. Another relevant construct for African Americans in this age group is the experience of discrimination or unfair treatment, disrespect, microaggressions, whatever you want to call it. But we know that discrimination is a well-established as an important psychosocial stressor for African Americans and has been linked with a number of physical and mental health outcomes. We were one of the first groups to look at this construct with cognition in older African Americans because most literature only focused on younger people or people in college, maybe middle age. And we found that higher reports of discrimination were associated with poor performance on cognitive function, particularly tests of episodic memory and perceptual speed. And this operated partially through depressive symptoms, which makes sense. In a separate study, we found that people reporting more discrimination also had higher levels of C-reactive protein in their blood. This was led by a colleague of mine, Dr. Tanae Lewis, who is now at Emory. And she found that people who reported more discrimination had higher levels of CRP in their blood, suggesting that perhaps inflammation might be a potential biologic mechanism linking discrimination to poor cognition. Data from another study that is sort of consistent with this idea of stress having an impact on cognition was done by one of my former postdocs, Dr. Arlena Turner. In this study, she looked at the relationship of perceived stress using the Cohen perceived stress scale. This is a scale that measures the degree to which a person finds their lives unpredictable, uncontrollable, and overloading. And she found that African Americans who reported higher perceived stress had faster rates of cognitive decline, most strongly seen for episodic memory tests and visual spatial ability tests. And we can also measure how people cope with these stressors. So there's another social construct called John Henryism, which was measured by a scale that was developed by Sherman James to measure coping capacity or coping abilities, mostly in African-American men with cardiovascular disease. So, we use this scale to see if we could see a relationship with cognition. This was work that was led by another former postdoc, Dr. Aloysia McSorley. And she found that those adults who reported higher levels of John Henryism, which is really a measure that looks at the tendency to use high effortful coping in the face of stressors. She found that those adults who endorsed more of this capacity or this tendency, they had lower cognition. And this was an effect that was similar in impact to having fewer years of education. We've recently begun to interrogate the social environment as a potential risk factor for poor cognition. And this is work that's being led by, again, by Dr. Lamar in our group. And this map shows Chicago, and the purple dots are our participants. You can see they're really quite spread out over Chicago, but mainly concentrated on the south side of Chicago. So we geocoded, all of the participants' residence addresses. And the study, this study led by Dr. Lamar, we computed a census tract derived social vulnerability index, which is an index from the CDC that's composed of characteristics of the neighborhood, including socioeconomic status, certain household characteristics, racial and ethnic minority status of the neighborhood, and types of housing and access to transportation that a neighborhood has. And what she found was that higher neighborhood level social vulnerability, so those neighborhoods that were, had worse conditions, if you will, that those participants living in those neighborhoods had lower levels of cognition at baseline, and especially in episodic memory. And she also had Latinos in the study. I'm just showing you the results for the African Americans here. It was a similar finding for Latinos who, tend to also live in these sort of disinvested types of neighborhoods in Chicago. So, I've shown you a lot here, but I think the main point is that, there's some traditional risk factors that seem to operate, pretty similarly, except for maybe some of the genetic markers. But, we have these risk factors that are relevant to the lived experience of older African Americans that, also seem to mostly affect level of cognition. I've shown you some things about the social context, where one is born or educated and how that has an impact on cognition, experiences of unfair treatment or their perceptions of stress, how they might cope with stress, and even the neighborhood context. All of these things seem to have some bearing on how these older Black adults are performing on these cognitive function tests. And so next, in the last 10 minutes or so, I want to go through a study that we're now currently writing up to look at the underlying brain pathologies in our African Americans who have come to autopsy. Again, our study encourages brain autopsy, but it's not mandatory. So we don't have as many brains as we have for our white participants, but this is a growing resource. And we are, working very hard to get our numbers up. So in this study, we examined the association of diverse cerebral vascular pathologies, as well as profiles of single and mixed vascular pathologies with cognitive function in about 112 older community dwelling Black decedents, and we looked for potential racial differences with age, sex, and education in older white decedents who were matched, on those demographic features. I'm not going to show you those data. I'm just going to show you the profiles that we're seeing in our older Black adults. But we can talk about it in Q&A if anyone's interested about the racial differences. So we've also, we're also looking at the other pathologies that we know are present in the brains of these older adults. These neurodegenerative pathologies, including beta amyloid and tau neurofibrillary tangles, which are the hallmark features of Alzheimer's disease. And we're also, quantifying neocortical Lewy bodies and TDP-43, or late NC, as it's now called in the field. And so in this sample of 112 Black decedents, we found that 80% of those people who died, and remember, everybody enters the study without dementia. So 80% had any type of vascular pathology that I showed you on the previous slide. And 26% of those Black decedents had just a single vascular profile, while a little bit over half had mixed vascular profiles. So you can see the numbers in red there are the numbers of people who had mixed vascular profiles. And compared to those who had single pathology profiles, those with mixed profiles were more likely to have dementia in this small sample. And when we looked at linear regression models adjusted for demographics and neurodegenerative pathologies, we found that microinfarcts and arteriolosclerosis in the basal ganglia were associated with lower global cognition. All the other cerebral vascular pathologies were not related to cognition, just microinfarcts shown in the bold and arteriolosclerosis in the basal ganglia. When we looked at the association of single versus mixed cerebral vascular pathologies in cognition, we found that it really was the mixed cerebral vascular pathologies that were associated with lower episodic memory and perceptual speed. So this is consistent with the fact that the mixed vascular pathology profile was associated with an increased risk of dementia. It was, it's driven by performance in episodic memory and perceptual speed, so that makes sense. Again, single pathologies were not related to cognition in this cohort, so it's really given us this picture that, vascular pathology is important in these older Black adults, but it really seems to be the mixed vascular pathology that's important. If you just have a single type, it doesn't seem to be driving anything, but once you have the accumulation of multiple vascular pathologies, that's when you take the hit on your cognition and your risk of dementia. So I've shown you a lot. I know it's probably overwhelming for me too. But I hope that the message is clear, that cognitive decline, is a hallmark feature of dementia. But, when we look at change over time, which is the process of aging, which we should be looking at, not just cross-sectional differences, but longitudinal differences. When we look at that over time, we don't see any racial differences in cognitive decline. We only see differences in level of cognition. And so it suggests perhaps that the higher risk of dementia in this population is likely a function of differences in cognitive level where people start. And so identifying risk factors for level differences could provide opportunities for prevention and intervention studies. So there's some traditional risk factors that seem to operate the same across race, like BMI, but others have a more nuanced relationship, like ApoE and maybe even neuroticism. Risk factors operating simultaneously could also provide further clues to the level effects, like I showed you in the study with depressive symptoms and purpose in life, and it may suggest opportunities for resilience. I think an exclusive focus on African Americans, as I'm doing in Mars, allows us to measure risk factors that reflect the lived experience. These factors appear to also be associated with level of cognition in older African Americans. And there's many more that we haven't even looked at yet that could be playing a role in this population. When we look at the pathology data, we see that mixed cerebral vascular pathology profiles are common and appear to be a significant driver of cognitive impairment in this population as well. Future studies that link risk factors to the underlying pathology will help us understand how risk factors are getting under the skin to lead to cognitive impairment. So as our numbers accrue in the autopsy portion of our study, we'll be able to start looking at how these risk factors are operating through pathology. In our studies of whites, we have not really found that these common risk factors operate through our known pathologies. So there might be a similar finding in older Blacks, we don't know. I want to just say that Mars has become a rich resource for the field, and it really offers additional opportunities for increasing our knowledge of cognitive aging. Because it's become this great infrastructure, there are many studies now that have used the Mars infrastructure to get their grants funded. So we have, neuroimaging studies and omics and plasma biomarkers and decision-making, nutrition science. We have studies looking at the social exposome, and a lot of studies now are starting to look at participant perspectives via mixed methods. So really a rich resource for the scientific field, I think. I want to acknowledge the funders for the work that I do. Really generous funding from NIA and Alzheimer's Association and Illinois Department of Public Health, and my chair, Alla and Solomon Jesmer family. And also the study participants, because without their participation, we would not have any of these data. So I have a deep debt of gratitude to the Mars and MAP participants, as well as our population-based study, where we often go back and look to see if results we're seeing in Mars can be replicated in the population-based setting. And I want to acknowledge the faculty at the Rush Alzheimer's Disease Center and our strategic partners for the work that we all do as a collaborative group. And finally, if anyone's interested in the data that I presented today or any other data that I didn't present, you can go to our RADC Research Resource Sharing Hub to see what types of cohorts we have and what types of data. And happy to collaborate with you, but I don't need to be a collaborator. We share data widely, whether or not we collaborate with you at all. So thank you for your attention, and I will turn it over to Dr. Gleason.
Great. Thank you for a wonderful overview and a couple of questions, and maybe I will start off. I think I was struck by the difference in the initial cognitive level, which strongly suggests some developmental contributions. And so maybe can you share some insights into how some of those, whether it's premature birth, or other things, early age exposures that may determine the level of cognition in addition to the number of the exposures that you're talking about?
Yeah, that's a good question. I can't speak as much to developmental issues because I see people at 65 when these differences are already in place. But certainly, people have looked at cognitive test performance in middle-aged adults, and you see similar findings. I'm not sure of the pediatric literature. I don't know when these differences emerge. But I think we cannot rule out testing differences, right? So it could be developmental, but it also could be a function of how these tests are developed and normed and who they're normed on. And so, because of the stark differences in educational experience and exposures, and how, we live in really segregated societies in the US, unfortunately, Blacks and whites have very different upbringings and social conditions and exposures when it comes to educational experience. And that could impact how they develop and how they, eventually age and take these tests. So I think it's an interesting question, but I don't know. Is it developmental or is it still really social, at the end of the day, right?
Right. Well, the developmental is social too, right? When you think about the environmental exposures during critical phases of organ development and brain development, right?
Absolutely, absolutely.
Yeah, great. Maybe I'm going to rephrase one of the questions a bit and talk about how do you build trust in a population to get them to agree to donate their body, particularly brains, for research, particularly in vulnerable populations that have not had trust
Right.
with clinical research in the past. So what is your approach for that?
Yeah, it's a great question and very very detailed in that it takes a lot of time. I mean, I cannot stress the amount of time that it has taken us to build trust. And I thought when I came into this that, oh, I'm African American, it's going to be a piece of cake. They're going to give me their brains like that. No, that's not how it works. Yeah, I'm African American, but I also represent Rush and, and all the baggage that might have for African Americans. And so our approach has really been to give first. So before I even started Mars, I was in the community, getting people to know me, working in the community, doing health fairs, giving, educational seminars, talking about brain health, brain aging, really talking about research and why it's important and how African Americans are absent from research and why that has to change. And really just sharing my passion and my motivation for doing the research. And I did this for a few years before I actually went in for my first RO1. And whenever the community wanted something, we were there, sponsoring things, just helping in whatever way we could, always trying to give first. And so when it came time to write the first grant, I had to get letters of support. And I went back to these community partners and I got tons of letters because they knew me and they trusted me because I had been working in the community for several years before I asked anything. I was giving first. And then when I got the grant funded, I got 200 people enrolled in the first year because of these community partnerships, but again, I was still working on building trust. So it wasn't a done deal just because I enrolled people. I had to continue to show that I was trustworthy, that my team was trustworthy by giving results, reporting back to them what we're finding, going to them, asking them, what do you think should be in the study? What kinds of questions should we ask? And having that back and forth exchange and just always, being a face in the community. Then that allowed me around the second cycle of the grant to start to incorporate brain autopsy. And it started with education. Like, why is it important to get your brain? And what are we going to do with it? And it took a lot of, education. It still takes a lot of education because I don't have full, buy-in yet. But slowly people, converted. Some people were like, yeah, sure. Other people, it takes a little bit more time. The hard part that we have is the families, because we can get participants to agree because we've been with them for 20 years, but they have to tell their family because that's who's going to call us when the person dies, right? And that has been the biggest hurdle because the families aren't participants. So we've now started to incorporate different things to get families on board. I, wrote a grant to have a social worker, on the team, and I have retention specialists now. And so they create family programming so that we can start to get families involved to understand why this is so important. And slowly the numbers are growing over time.
Great, thank you. So a question from Dr. Johnson about the MRI-derived vascular disease estimates. Does the MRI map onto the neuropath data? And, wondering if you see similar effects in vivo as you do with the neuropath data.
Yeah, thank you, Dr. Johnson. I didn't show those data today, but yes, we are seeing similar findings. We have a metric called ARTS, which is arterial sclerosis for for in vivo imaging that maps very closely to what we're seeing in the neuropathology. And of course, in a much bigger sample, and we see that people with more ARTS or faster ARTS decline, increase, people have more accumulation of arteriosclerosis over time, have faster declines in cognition. So I didn't show you results for decline with autopsy, obviously, because, you know, when you die, we just look at your approximate to death. But in our neuroimaging studies, we do see very similar patterns. So it's gratifying that we're seeing the same thing in vivo as we're seeing postmortem.
And then another question, did you look at non-vascular coexisting pathologies in Black decedents? And if so, were they related to cognition, and were there any differences with the white population?
So I'm assuming they mean neurodegenerative. So like also amyloid and tau, Lewy bodies, things like that. I'm assuming.
I'm assuming since it's Dr. Estena, so yeah.
Okay, we did look at that, and you know, we're seeing similar relationships across race, interestingly. So we don't see any racial differences in the burden of amyloid and tau in our African Americans compared to our white Americans. We see a very similar relationship where, you know, if you have amyloid and tau, it does lower your cognition a bit, but it really, you know, the bigger effect is driven by the vascular pathologies that I showed you, because in those models, we controlled for the non-vascular pathologies. And then when we look at the racial difference, we see a very similar pattern, except for it looks like microinfarcts are a bit stronger in the relationship with cognition for African Americans than for whites.
Okay. And then a more general question, you talked about depression as a modifiable risk factor. Should we be screening more widely for depression as a risk factor for dementia in primary care and specialty care?
Yeah, I mean, you know, I think so. I mean, it's you know, it's coming out to be an important risk factor across many populations, and we know that older adults, especially older African Americans, you know, there's some underreporting, I think, of depressive symptomatology in this population. So I think, you know, being able to screen for it in primary care would be really beneficial, and then help us, you know, maybe intervene earlier before people are at risk for cognitive decline.
Then maybe Dr. Gleason, since we just have a minute, do you want anything that you want to add?
I will just end by just thanking Dr. Barnes for a fantastic presentation and for the body of work that she's generating. Incredibly impactful and important work. So thank you for sharing it with us today.
Thank you, Dr. Gleason.